Okay, let's just dive right into this explainer. When we hear the name Niels Bohr, most of us immediately picture the atom, right? You know, that classic image, a nucleus in the middle with electrons zipping around it like tiny planets. But honestly, if we just look at him as the physicist who mapped the atom, we're doing him a massive disservice. Niels Bohr wasn't just a scientist, he was a truly profound philosopher. He was a thinker who literally had to break classical Newtonian logic just to redefine human understanding. So we're going to explore how this one man completely bridged the gap between strict scientific mechanics and the deeply paradoxical nature of reality itself. To really set the stage here, listen to this quote. No, no, you're not thinking. You're just being logical. He actually directed that rebuke at none other than Albert Einstein, which sounds totally counterintuitive, right? I mean, shouldn't thinking be logical? But Bohr understood something incredibly fundamental. Rigid, deductive logic can actually blind us to radical new truths, because sometimes nature just doesn't fit neatly into our preconceived little logical boxes. And true intellectual breakthroughs, well, they require a completely different kind of thinking altogether. Part 2. Architect of the Quantum Era. To understand a mind like Bohr's, we really have to look at his roots. He was born in 1885 and grew up in this incredibly sophisticated Danish household. His father was a Nobel-nominated physiologist who actually hosted these interdisciplinary intellectual salons right in their living room. So growing up, young Niels was constantly listening to scientists, philosophers, and writers just actively debating the world. And that environment instilled in him a profound, lifelong belief in the absolute unity of all human knowledge. Literature actually directly influenced his science. There's this fantastic quote, "We are both onlookers and actors in the great drama of existence." This stems from Bohr's absolute fascination with a Danish novel called The Adventures of a Danish Student by Poul Martin Müller. In it, there's a passage where a student becomes literally mentally paralyzed by observing his own thoughts. The eye observing the eye. And for Bohr, this wasn't just some fun literary paradox. It actually sparked a realization that became the very bedrock of quantum mechanics. He realized that humans are inextricably bound to the universe we're trying to measure. We literally cannot completely separate ourselves from the experiment. Moving to part 2, the quantum atom breakthrough. That philosophical flexibility we just talked about, it became absolutely vital. By the time Bohr earned his doctorate in 1911, physics was in a massive state of crisis. When he encountered Ernest Rutherford's atomic model, the one with a dense nucleus and orbiting electrons, Bohr instantly spotted a fatal theoretical flaw. Under the strict laws of classical physics, those orbiting electrons should just continuously lose energy and spiral catastrophically right into the nucleus in a tiny fraction of a second. Basically, classical physics was telling them that atoms couldn't exist, which is crazy. So Bohr realized the old classical rules were just totally invalid inside the atom. And this realization led to a staggering 3-year intellectual evolution. In 1911, he writes his doctoral thesis basically proving classical physics has insurmountable limits. Then, by 1912, after actually being dismissed by J.J. Thomson in Cambridge, he transfers over to Manchester to work with the incredibly boisterous experimentalist Ernest Rutherford. Fast forward to 1913, and he publishes a series of 3 papers famously known as the Trilogy. So in just 3 short years, he completely rewrote the rulebook of reality. The ultimate result of all this was the Bohr model of the atom. To stop the atom from collapsing in on itself, Bohr boldly merged classical physics with Max Planck's quantum of action. He argued that electrons don't just radiate energy continuously. Instead, they occupy very specific, discrete, quantized orbits. They only emit or absorb energy when they instantaneously jump from one level to another. It was a massive conceptual leap of faith. But miraculously, it perfectly explained atomic stability, the spectral lines of hydrogen, and it finally gave chemistry a coherent explanation for the periodic table. It was a real game changer that fundamentally changed science forever. Part 3. The philosophy of complementarity. But Bohr didn't stop at the atom. As we move into the 1920s, quantum mechanics kept evolving, and a massive new crisis of interpretation emerged. Subatomic entities, like electrons, were behaving incredibly weirdly. Paradoxically, they acted as continuous waves, like ripples in a pond, but sometimes they acted as discrete, localized particles, almost like tiny bullets. Under classical logic, something simply cannot be both a wave and a particle at the same time. It was a total brain-bending paradox. Bohr's brilliant solution to this paradox was the principle of complementarity. He essentially argued that wave and particle behaviors aren't these contradictory realities just waiting for a better classical theory to sort them out. No, they are complementary. The microscopic world simply does not possess definite, fixed properties, completely independent of the experimental apparatus used to observe it. Think about it like this. If you set up a wave experiment, you get a wave. If you set up a particle experiment, you get a particle. Both are absolutely necessary to fully understand the system, even though they are totally mutually exclusive. And this perfectly sets up the greatest intellectual clash of the 20th century. On one side, we have Bohr's Copenhagen interpretation, the idea that reality is fundamentally probabilistic, indeterministic, and entirely bound to the observer. On the other side, we have Einstein's worldview, a firm, unshakable belief in an objective reality that exists independent of observation, governed by deterministic hidden variables. Einstein famously insisted that God does not play dice, but Bohr's framework shot back, insisting that it's fundamentally meaningless to even assign classical properties to quantum objects before you actually measure them. It's a debate that literally forces us to question the very fabric of reality itself. Obviously, the sheer magnitude of these theoretical breakthroughs just couldn't be ignored. By 1922, Niels Bohr was awarded the Nobel Prize in Physics, firmly cementing his status as the patriarch of modern physics. But the ultimate test of his worldview wasn't actually going to happen in a quiet laboratory. It was going to play out on the world stage. Part 4. The Bomb, an Open World. And this brings us right to the brink of World War II. In 1939, using his liquid drop model of the nucleus, Bohr actually provided the theoretical framework that inadvertently explained nuclear fission. Basically, without ever intending to, he had unlocked the core mechanism for the atomic bomb. Suddenly, this deeply moral, thoughtful philosopher was thrust right into a terrifying geopolitical paradox of his own creation. From there, his own survival literally became a spy thriller. In 1943, Danish resistance intercepted intelligence that the Gestapo was coming to arrest Bohr because of his Jewish heritage. So, he was secretly smuggled by a fishing boat to neutral Sweden. After that, the British flew him out in the bomb bay of an unarmed mosquito bomber. And here's a crazy fun fact from our sources. Bohr's head was apparently so large that his flight helmet didn't fit, so he couldn't hear the pilot telling him to turn on his oxygen. He actually lost consciousness and nearly died at high altitude. Luckily, he survived, arrived in the U.S. under the fake name Nicholas Baker, and joined the Manhattan Project at Los Alamos. There, he acted as this vital technical and moral guide for the other scientists. But here's the thing. Unlike many of his peers who were laser-focused just on the military objective, Bohr was already thinking 2 steps ahead. He correctly anticipated that keeping the bomb a strict secret would inevitably trigger a catastrophic U.S.-Soviet arms race. So, he embarked on this totally unsanctioned, incredibly courageous diplomatic campaign for transparency. He even managed to meet with FDR and Churchill in 1944 to beg them to tell the Soviets about the bomb before using it, just to build trust. Churchill was absolutely furious and actually almost had Bohr confined. But Bohr didn't quit. In 1950, he published a passionate, open letter to the United Nations pleading for an open world of absolute transparency to prevent nuclear annihilation. Bohr firmly believed that if politics couldn't unite the world, well, science had to. Using his immense global influence, he became a massive institution builder. He was a founding father of CERN in Europe and Nordita for the Nordic countries. He even toured India in 1960. There's this great story where he was debating physics so intensely with some students late into the night that he absent-mindedly shoved a still-burning smoking pipe right into his suit pocket. But that very visit directly inspired the Indian government to create Mat Science in Chennai. He was literally fostering scientific collaboration all across the globe. Part 5. Lessons for Modern Life. So, what does this all mean for us today? Bohr's life is obviously a masterclass in physics, but honestly, it's also a highly sophisticated framework for our daily existence. Let's take Bohr out of the laboratory for a second and apply his core philosophy to our everyday struggles. Let's look at how we can actually apply complementarity right now. In our own lives, we are constantly facing opposing imperatives, right? The aggressive drive for career ambition versus the quiet, steady presence needed for family. Logic versus emotion. Bohr teaches us that we really shouldn't treat these opposing imperatives as problems that we have to solve by just eliminating one side. Instead, they are complementary aspects of the human experience. We grow when we can comfortably hold mutually exclusive truths in tension. We have to practice intellectual humility, embrace openness over secrecy to build real trust, and always adapt our logic to what nature reveals rather than forcing nature to fit into our logic.
I love this detail. When Bohr was knighted with the Order of the Elephant in Denmark, he actually had to design his own coat of arms. He chose the yin and yang symbol along with this motto, Contraria sunt complementa. Opposites are complementary. He just so beautifully articulated that while the opposite of an ordinary truth is usually just a falsehood, the opposite of a profound truth is very often another profound truth.
So, as we wrap up this explainer, I want to leave you with a question to chew on. How can you apply the principle of complementarity to hold two conflicting truths in your own life right now? Where are you being rigid when you should really be embracing paradox? Bohr taught us that we are all both onlookers and actors in the great drama of existence, so don't be afraid to drop your rigid logic and start truly thinking. Take that with you, and I really hope this sparks your curiosity to dive even deeper into the incredible legacy of Niels Bohr.